computer. So one approach, as you saw, one thing that I've tried before is, yes, a mathematical approach. And while I did like the math, I didn't like how I was trying to think about how would I represent that easily and be able to reuse that information. So I'm like, there's got to be another way of approaching and thinking about this. So again, I took a quick second. I'm like, so this is all I did. I'm like, how would I approach this in the real world again? So I'm asking myself again, how would I approach in the real world? And which is again a weird question to ask when talking about robbing a place. So I would have to ask myself, if looking at a set of houses, how do I determine the amount I could take away from it? Well, there is a concept of dynamic programming called bottom-up approaching, and also just what's called memorization or remembering. So we know that there's multiple variations or paths I can take on each one of these, right? However, as I evaluate each set of houses and find the optimal solution, I can reuse that information, right? And compare and contrast as I continue down the line. With every house, I have the option to either rob it or skip it. And that's going to create a scenario based on that as well. I can't rob two houses next to each other. So I have to decide, am I going to rob that house or am I going to move on to the next house? So I get to, those are some decisions. At the same time, if we think about it from the way of, let's do it this way, annotation, by the way. Annotations, where are, oh, there it is, button right there. It didn't click. Click, please, thank you. Then grab, yes. We go to a street and find out the street we went to go to rob house and has no houses there because they all got wrecked in a crazy tornado. So there's no houses. How much money am I stealing?
0.
Yeah, right. If there's another house and that house has some money in it. So here's my street. There's some money in it. I don't know the money, right? How much money though am I stealing?
Some money, all of it.
Right, X, right? I'm going to steal that money. Correct?
Mm-hmm.
All right. Then in the next one, if I have another street now, this was some money here and some money here, which one, how much money am I going to get away with?
Whichever one is
or the
larger.
other.
Right. Now, did we have a method or a term to use for getting a large item between two options or multiple?
Collections.max.
What is it?
Collections.max.
Max, right? We would say I would leave with the max of X comma Y, right? I'm going to grab the maximum one of that. Now, if I keep track of this stuff, these are very simple and straightforward. With the next one, I have to then assume is X, Y, and Z. Well, the option here could either be X and Z are more or Y is more, correct? Mm-hmm. And so in this scenario, I could think of those two options. First off, I would think of like, oh, between X and Y, I'm going to take the max of that. And then I'm also going to take the max of this versus the max of X and Z. So at max of X and comma Y versus the max of X plus Z, correct?
Oh, wow.
Correct? No, sorry. Well, yeah. No, it wouldn't be, right? It would be Y or X plus Z. Yes. Yes. Well, technically, no matter what, this would work because if the max of this is Y, but then the maximum here is of this, and then this is larger, I'm going to take this, right?
Right.
So in this scenario, if X is bigger, so this is, sorry, in this scenario, if Y is bigger, I'm either going to take Y or the maximum X plus Z. If X plus Z is larger, I'm going to take the 2. In this scenario, if the X was actually bigger than Y, I'm going to take Z no matter what, right? So I'll then I'll definitely take this one, wouldn't I?
Yeah.
So this is kind of what we're looking at. This concept of remembering as we've done each item what the next option is and using that logic to get moved down the line and to continue grabbing this concept. And so we could create some base cases. So that's the first thing I'll walk you through is that concept of base cases. and then again, an idea of memorization, of remembering scenarios. So let's look at this quick here. So first, I'm going to say, okay, well, if not for arrays, what is is it length or size?
Length.
Length. And is that a parameter or a method?
I think it's just a
Method.
property. Oh, is it?
Yeah, it's a property.
Oh.
Yep. It's not a method.
Oh, okay.
Nums.length is equal to is either this is either null or sorry, if nums, sorry,
0 or
nums
none, right?
is null or nums.length equal to 0. I don't think it can be null because int can't be null, can it?
No.
So I guess we don't need to check that. Like integer array be null. I don't think it can be. I actually don't know. I think an integer array is an array, so that would be an object, so it could be null. Never mind.
Yeah, it is.
Yep. Okay, so we can do that. So if nums is equal to null or nums.length, we're going to return 0. That's this street right here. So we can now get rid of that one. If nums.length equals 0, we'll go ahead and return nums 0. Sorry, wrong on that. I indexed it 1. We'll turn num 0. Right? So that gets rid of this guy. Let's do our last one. And even though I'm going to get rid of this array, even though it's the one we're doing, we're going to move it just so you can see what I'm typing. Nums.length equal to 2. Return max or collections.match max. Nums 0, comma, nums. We could probably actually just give it nums, actually. I just forgot about that. Nums, right? Max and nums as array, right? Ah, dang it. Wait, we have arrays max, don't we?
I think so.
Forgot about that. Yeah, you guys. remember that last time.
Collections.max.
I think we had arrays.max too, didn't we? We didn't? Did we?
Oh, it's taking it.
Like it? Cool. Okay. All right, so now we have that. So those are our 3 base cases, right?
Mhm.
So now what we can do though is also create, and now, how do I want to word this again? So we want to start creating a memory of our decisions on each scenario. So we know that if we have, and what we can do is create a array of the same length. This is how we do memorization. We create a data structure or usually a collection that remembers each indexes or each length option. So a length of 1 is of course index 0. So index 0, we can store what our total would be if we just robbed index 0 and nothing else. Our length of 1 says, okay, well, in a 2-length array, what would be our optimal steal in that 2-length array? We can then save that. And then from there, we can then continue to move on and start storing that information and start tracking that down. So what we're going to do now is I'm going to create an array of the same length as nums. So that, we'll call this, cache, memory, whatever you want to call it. Array. Yeah, just that, just like that. Yep.
Mhm.
Wait, no. How do you do length in Java?
No, you're
Oh,
fine.
that's right.
That's
Okay.
right. Yeah.
Not sure why that red squiggly wouldn't go away right away. Sorry, it got me to question myself. Well, I'm just going to pre-fill this collection with the already decisions we know we're going to make. So cache 0. So again, with just the 0 thing, with just one index, which is one element, we're looking at just the first item in the collection. We are going to, of course, return num 0. One. So again, now we're looking at the 2 elements of the array, right? So now I'm going to do, I think it's math.max as well. We can also do this one. I also introduced this one as well. This is going to be a little more useful for us because instead of giving it a collection, we're just going to give it 2 entities. So this is a different option. And this is going to be useful later on when we do additional maxes inside of maxes. So this is another type of max. So you have collections.max, which will take an entire collection and find the largest item out of that. The math.max will just take the largest item of the largest item between 2 integers, 2 doubles, 2 floats, 2 longs, anything of that nature. That. I'm not sure why math is gray. That's weird. That makes me feel like I don't need it, but I don't think that's it. We do num 0.
It's nums, not num also.
Thank you. You're right, it is. Problem later.
Nums is the word.
And nums 1.
Okay, so you know what? Never mind. Continue because I think you're going to
Yeah.
answer my question. So
Probably.
let's continue.
So the next thing, of course, would be to iterate from this point forward. These are the only definites. Everything else is dependent on additional knowledge and logic. And what I'm going to give you is just the the cache for index 2. And then I want people to extrapolate this. If you can figure out this line and understand how this caching system works, you'll be able to create the iteration, the looping
Don't forget
structure
the
that
E.
will grow this. What's that?
Don't forget the E for cache.
Thank you. .max, and what we're going to use here is be able to reuse some of our information. I'm going to do, so we're looking at nums2, same one we're looking at. So this is the idea of we're going to take this house, right? We're stealing from this house plus the optimal steal of 2 houses back. Because we can't steal the previous house. We can only steal 2 houses back. So I'm going to do cache 2 minus 2. So 0, technically. I shouldn't have done that. It's giving a little more than I wanted. And I have to E again. Comma. And the other result we're looking at is the previous house. Or we're going to keep the previous house and skip this one. Because the previous house, of course, the previous one is stealing that previous decision. If we steal from here, we can't take cache 1. That option is not in there. So now we're comparing these 2 scenarios and saving this scenario to here. Which one is the optimal? And again, if this one contains the house that this has, it's fine. We're going to end up picking this one. If the house here is better, we're going to end up taking this group. I want you to play with this a bit and take a look at it. The idea, of course, is us utilizing previous evaluations. That's what we're doing here. We're looking back at what we did. To look at this a bit on the one of the examples, let's do 2 examples here. We'll do 2, 2, 3, where the optimal solution is to pick these 2. And then we'll also look at it at 3, 4, and 3, where of course, that's wrong actually. I want to pick the middle one, so this would be 8 actually. We'll do 8. So this is the optimal solution. So let's look at what becomes of our cache array. Again, the cache array is our results. So cache index 0 gets what? Looking at the math here.
For which one? For the 3, 8,
We'll do this
3,
one
or
first.
the 2?
Let's do the top one first.
So that one's going to be 2
Yes, that's going to give us.
because you're immediately adding in 0, right?
I lost my pen. Where's my pen? Not my pen. There it goes. Okay. That's weird. That's it. 2. So then cache 1. What does that do? Look over to our left.
So it's gonna look for the next maximum number, which would be either be 2 or 3, and it's gonna be 3, correct?
Is it? It's index one is going to look at max of num0 and max of num1. So we'll look at these two items.
They're the same.
Means
They're
it's
the
going to
same,
just
so
return.
it's gonna do nothing then, right?
No, it'll return the maximum value, which is since they're the same, it still returns the value. That is the value. So it'll return 2. Yeah. We probably should change this later so you can see again. This one maybe I should make that a 1 later, but for now it's fine. Or I'll make it a 3. So you have 2. Now let's look at how this works. So now we're looking at nums2, which is 3.
Wait, can I ask you a question? This is actually what I was gonna ask you before, and you just said, I said you might answer it.
Go
So
for it.
you automatically give it, on line 13, you automatically put 0 in there, the index of 0, right?
Yep.
On the second one, you compare 0 and 1, and then you put whatever is the biggest one, but 0 is already in there, so if 0 is the biggest one, why would you put 2 in there?
Again, we're
Two
just
of the
we're just
same
storing
one.
here what the optimal money is. So keep in mind, our program here doesn't need to know what houses we stole from, do we?
No, I'm
We just need the
asking,
amounts.
why is it choosing 0 if 0 is already in there? That's what I'm asking.
Because it might not. So because this is 3, it's going to pick what?
It's gonna pick 1.
Right. So again, you have to be able to handle all scenarios. If it's a 1, then yeah, it's going to pick 0 again. We don't know what it's going to pick, so we have to give it the option to pick either one depending on the scenario. So again, I can change this to 3 later, or to 4, or to 1. Doesn't really matter. But the main thing here is we got 2 and 2. So now we look at this. So nums2 is our number 3 plus our cash of 0. This house. If we're going to steal this house, we get whatever the best result was before, not including this. Whatever the best result is of everything to the left of this house here, which is what this cash is doing is keeping track of our best money with just those houses involved. So 0 here is the best money of one house. It's the best money we can get stealing from only the first house. Index 1 is the best money we can get with stealing from 2 houses side by side. See how that's working? And so we're saying, hey, add 3 to the optimal house of this guy right here. Because that is going to be what the best is, whatever the best is of the previous stuff. So we take a look at that. That's going to give us 3, 4, 5. That gives us 5. Otherwise, tell me what the optimal solution is of taking this house plus everything before it. That's what cache 1 is storing, saying, hey, cache 1 is the second house and first house in the optimal solution. As you grow this array out, you're still including all the previous stuff. And so what this is going to do, cache 3 is going to say, okay, cache 3 is what the most money I can get comparing all the houses together. As we see, this is going to be cache 1 is just 2. So between 5 and 2, what's the optimal amount? What's max? Come on, people. Come here with me. What's the max? 5, right? I heard that.
Yes.
That's our money, right? That's what we want to steal. That's the maximum we can get out of this street. I'm going to do a couple larger ones so you can see how this works. We'll do this one first, though. Then we'll do a couple longer ones. We'll do some of the examples they had over there. So let's do the caching again. So cache 0, what does that store? Again, the optimal solution, looking at just this. What is the optimal amount of money I can steal with just that house?
3.
3, yep. Move this over. Cache 1 is now what is the optimal amount of money I can get from this house, from these 2?
8.
8.
Good. Move again. Now we're trying to say the optimal solution of this whole street, again, looks at the current item plus the optimal solution of everything before this guy here, which if we know, again, this is everything including that, this is everything before we add the 8 to it. So this would be 3 plus 3, which is what?
6.
Thank you. Or Again, keep the optimal solution of the previous steal, which is
8.
8. Which one do I keep?
8.
So I don't take on that other house. I just keep that one. And this is the solution I wanted, isn't it? Now let's try one of the bigger ones and see if this holds up. Because I know some of you are like, I can't see how this saves my decisions. How does this save my decisions, right?
Mhm.
So let's take a look at a larger example. Does anyone have the larger example from the other site?
How about 4, 9, 7, 1?
Right, clear. All right, what is the optimal solution? I already know what it is, just
4 and
looking at it as a
7.
human.
Yeah, 4 and 7. That's 11.
7 is making me 11, that's gonna be 10. Let's create our cache array. So again, the first one tells me again, what is the optimal amount of money I can get stealing from one house? Let me add my block there again, so you can keep an eye on what the cache means. So the cache is telling us, out of this, what is my optimal?
4.
Let's move our array. Again, this is bottom up. Remembering doing small solutions and then using them to solve bigger ones. Between 4 and 9, what's our optimal?
9.
Cool. So again. So now we have 4, 7, and 9. So, and now again, we're going to be using this. We're using the 7. Technically, if you really want to be honest on this, let me do this now. Our system is actually ignoring this. It's looking at the 7 plus my memory of what I've done before.
Okay.
Remember? It's
Mhm.
not looking at the array. We need the array to make sure we know what's going on, I guess. Well, actually, no, we don't. I'm not going to use the array. Good. Yeah, I'm going to hide that. So we have our 7, which is right here. And we're saying, okay, again, the optimal solution of my 2 houses prior, because I can't steal from the house before. But the previous one here might have that previous house. Contains all the possible houses I could steal if I steal from this one. This will contain all the optimal, this could contain all the houses I have. The problem with this one is that this one might contain a house I can't steal from, right? We don't know if it does, but it might contain a house I can't steal from. This one, though, we know it can't contain a house I can steal from. I'm sorry, it can't contain a house I can't steal from. And it's giving me the best option. So that's why we're doing 7 plus 4 for that option. The previous house, again, is all the previous houses saying, and this is something I can pick if I choose not to steal from this house. And that's what this option is. This is saying, I'm not going to steal from this house because if the previous option is better, I want to steal from that house. Again, it's a weird thing to say. I want to steal from that house, but it's true. I want to steal from there. So what is the option? What's the result of the cache 1?
9.
Right. So max between these, we have 7, 8, 9, 10, 11, and 9. What's our optimal?
11.
So that goes into our cache. So now let's use the last one now. So let's move our blocks. I'm gonna move my 7 over here, and this is gonna move over. So now we no longer have that number we just looked at. So I'm gonna get rid of all that. Try to forget the number we just looked at. I'm not gonna say it. But let's look at our previous again. So now we have our number 1. Again, I did not steal from the previous house. I can't use this one because this one might have stolen from the previous house. So I can't use this guy. I don't know for sure if it has or hasn't. This one is safe. This is telling me all the houses prior to the previous house in mine, what is the optimal steal? What is the best scenario here? And that's why I can use this one to make my decision. I know this is the optimal result. So add the 9 to it. That tells me if I stole from this house, I'm gonna get a total of 10. Or the previous house, which may include the house I can't steal from, is that a better option? Should I keep that house instead? What is my max?
11.
11.
There's our optimal. That's what we want,
So
right?
we'd have to loop through to get that last one though, because we're only looking at 3 indexes of num. Or, are we looking at enough indexes of nums to get that as it's written right now? Or I'm just
That's
trying
what
to
I mean.
follow along with the code. The
So
code that
this
you
is the
have written
same
on,
length of it. Yeah, we've gone through all the houses. See?
it's the same length, but you're hard coding indexes 0 and 1 and 2 in what you have
0 and
written
1.
there.
Yes, I am not looping because again, I told you that
Okay.
you need to turn this into a looping
Right.
system.
Okay, right. I'm just making sure I'm following along with that
Yeah.
because I got a little bit lost on that last one because I was just
I
looking at
don't
the
want to give you
code.
the
Right,
last
right.
bit of code. Yes.
Oh, that's fine. If that's not there yet, that's fine. I didn't want to
Yeah.
be too lost. Right.
Do we want to do one more example with 5 houses? Anyone have one or can come up with one? Hell, come up with one on the spot and we'll
Do that test
Tell you.
case 23, whatever it was.
someone have it. Again, if you don't have the example from the solution, but you're just going to come up with one. you
23?
can- What's that?
Test case 23?
I don't have 23.
I have it.
This case 24, but that one's got 13.
And I
integers.
don't know how the numbers are, but
Well, let's get that one.
I don't want to do that many. You can do that one if you want. Someone give me a test case. We can do 6 or 7 of them. I'll do up to 7 max. Find one that you can't tell what the optimal solution is just from glancing at it. Come up with one off the top of your head. I don't care.
Test case 20 is 8. I don't know if that's just outside of your realm of.
Go for it.
I'm gonna
Read me the numbers.
4, 1,
All right, come on. Yeah, I wrote 8 because I thought you would tell me 8, not the case number. So 4,
1, 2, 7, 5, 3, 1, and expecting 14.
expect to get 14. All right, that's the optimal number. Now, in this case, I don't actually want to know what houses are the optimal solutions. So I'm going to do this to you right now. Stop looking at the array right away. I'm going to cut off all of this right now. Another one, same length, so I can use that on the other side. So, because again, we actually don't care which houses we steal one from. We just want to get that largest amount of money, right? And our computer cannot look at the entire array. We cannot. And so sometimes this can be helpful to hide the information and just go through the way a computer would. So let's build our caching. So again, the main reason why we build these two definitely get built by default because there's no logic really here. There's no conditional logic of looking at our past because these two have no past. We have to, this is just the base scenarios we came up with where there is no deciding factor of, well, based on what I did before, changes what I do now. It's once you hit 3 houses, do we have to now decide, well, depending on what I do before, I'm going to do something different. So yeah, let's look at this now. So let's build our memory. What's the first one?
4.
Good. We'll go ahead and move this. Now the first one does still look at the first 2 numbers. So what is it?
4.
Good. Now I'll start moving them side by side. So move that over there. That goes over here. Now on index 3, again, we take a look at our 2 plus again, this one here, because we know this one does not steal from the second house, the one that we're not allowed to. We know this one doesn't. So that's 2 plus 4. This
6.
one might steal from the house. We know we can't. We as humans don't know this one didn't steal from the house. We're not allowed to steal from. But our computer doesn't know that. But this showcases that the system will just end up picking the right scenario then. It's going to pick where to steal from this one on this side here. It might with this one decide to not steal from here, but again, you'll see how that works. We'll keep moving forward. So 4, 2 plus 4, this gets 6 over 4. What is our optimal steal for this length? 6. Good. Let's move everything over. Oops, got a chat. What's going on? Oh, bye, Airden. Let's move this over 1. Let's over again. Now let's take a look at this. Right here, yeah, you might be thinking now, again, you have better memory than the computer. You might be thinking like, oh, wait, maybe we should steal the 7. Wait a minute, maybe that 2 isn't what we want. Even though right now we're saying we do steal the 2. But now we have our 7. Let me go ahead and delete all this stuff here. Not that. Put that back. Oh, I want the 14 though. Ah, crap. Put that over here actually. So I don't accidentally do that. There. So 7 plus this cache. Again, this one might, again, speaking computers, this one might contain the house we're not allowed to steal. We as humans now going through this step by step, we know that this house, this cache here does contain the house we cannot steal from. That's why we skip, we don't include this one, because this one cannot, under any circumstance, no matter what the numbers were, it will include the house we're not allowed to steal from. You're right, Taylor?
Yep, I'm fine. Go ahead.
Okay. Like, did I say something funny?
Don't worry about it.
Okay. Probably has someone speaking in his ears. 7, so yeah, we got that plus that, so plus 4. Otherwise, again, if we skip this house, we're only going to be able to take this, so 6. What is our optimal scenario here?
4 and 6.
Not 4 and 6, 7 and 4, right?
11.
11 or 6. We skip this 7. Which one's max?
11.
Thank you. 11, steal from this. In the scenario where if the array ended here, we would want to take this scenario, this 7. That's what it's currently telling us. If our array ended here. Now the next number could be a 20. And again, that's what's nice about this caching system. This is going to tell us that if the next number again is another higher number, we could still potentially take from this, say, you know what, okay, yeah, you know what, don't take the 7, take the 2 and the 2 and the 4, take that scenario again. That's what's really nice about this approach, is that because we're remembering the best scenario of the current approach we've taken, and we're looking at 2 results of the optimal solutions, we keep constantly moving this along, we're reevaluating every single time what is the optimal item, and then always taking the optimal, you're going to slowly see it's going to get us what we want. Let's see if it does work. This over, this over, we got a 5. Let us see. So get rid of that, get rid of that, get rid of that. We got a 5 plus, I'm going to take the 6. We don't know this, we know this one didn't include the house, the 7. So let's get the 6 here. What is the result there?
11.
11. And then our current best with the previous house is also 11. So what's the max of 11 and 11 again?
11.
Which again is technically true. If the array was to end here, our optimal, the most amount of money we would get is 11. Do we really actually care which houses we stole from? Does the algorithm want to know what houses I stole from?
Oh, no, it just wants the total.
Nope.
Exactly. So I don't need to know which house I stole from. I just need to know, yep, 11 currently is still my best scenario.
Oh, wow.
That over again. Let's grab this one. 2 more. Okay. Got our 3. Let's go ahead and get rid of all this. Let's add more to our memory. So 3 plus this one we know doesn't contain the house we're not allowed to steal from. If we steal from this one, so 11, that gives us 13 versus 11. What's our optimal? What's our optimal? Blech.
14.
Thank you. So that's that one. Let's move one more over. You have the 1. I think we know what the optimal item is going to be here, but let's just confirm. 1 plus, again, this one right here does not include the previous house. So we'll grab the 11 or 14. This gives me 12, 14. What's my optimal?
14.
14. And that the end of our memory is the optimal solution for all houses involved. Is that the number we were looking for?
Wow.
Nice.
Okay.
Memorization and keeping track of each decision as we move forward and comparing that. So comparing our current decision based on our previous decisions, using our previous decisions to pick our next opinion. This is that concept of a bottom up, seeing like, you know, yes, lengths of 0, 1, and 2 have a very standard answer, right?
Mhm.
It's not until we get above a length of 2 do we actually have to make some logic, and then we can say, you know what, okay, well, let me remember my previous 2 decisions, and then using those decisions, I can then make a decision of what my optimal is, save that decision, and then move forward again, and keep moving forward to save my decisions as I make decisions, and use that information to justify or to change my next decisions. And this is that bottom approach. So look for that kind of stuff too. This concept where I can use smaller pieces to build on top of it. And so this is a bottom-up approach using memoization. Memoization. That one. Remembering stuff. And so what's the real benefit of this one is, if you think about it, we only have to go through the array once, right? The previous solution I was trying to come up with, I wasn't really happy with because I knew it was going to be a very brute force, kind of multiple times through the array, multiple times having to update and change information and run calculations. This time we go through the array once, because that's really how we're going to be deciding things. As we go through, we're going to change our decisions based on the next house in the scenario, right? On every house, we're just deciding, am I stealing from this one or am I skipping it? And that's what this system here is helping us to decide, am I skipping this house or grabbing this house? If I grab from this house, let me save that so that way I can decide again the next house, was that a smart choice? So every house allows me to then evaluate, was my previous choice actually the best choice, or should I adjust? That's what this is allowing me to do. Any questions on this? No questions? I actually expected questions. Did the blocks actually kind of help you to kind of see what the computer was doing? The blocks actually help. So feel free to restrict yourself on that. But yeah, these are some, again, these are just techniques and tools. So memorization, math is something you can use. But I realized after on Thursday, like, not everybody here is a math crazy person. We want to go doing all this numbers and messing with numbers. So let me again, I went back to the drawing board of just, let me approach it from a non-mathematical standpoint and just look at it as I would do it from a human. I would do some basic math, but I'm not going to add them all up and add left and rights, then eliminates from left and rights. I'm like, that is not something I would actually do if I wasn't a math heavy person. Make sense?
Mhm.
Cool. All right. So like I said, I'm not doing the final result. I gave you kind of the buildup and the structure of a memoization system, a caching system where you can remember as you do. Your goal of this is to actually convert this into being able to build on top of it and grow into any length of array. So we'll leave that for you guys for next week. I will then show the solution and have you guys share your solutions. If however you do think you have another solution that you think you're close on, feel free to finish that one. I would love to see alternate solutions to this. But I did want, this is the concept of dynamic programming. This is one method of dynamic programming. Yeah, memoization and bottom up. So using smaller pieces to solve a bigger solution. I feel like Matt might have gotten it. He just had a face.
One minor thing though, arrays dot max is not a thing.
It isn't?
Yeah,
Oh.
according to code signal, it is not. So you're gonna have
Fine.
to. There's a small workaround for it. It's not a big deal, but let me do a final submit on it. Make sure it hit all the test cases. Wow. Damn, that's cool.
Matt might have it, so I don't want to get stuck. You guys can reach out to Matt. All right. Yeah, I'll let you guys apply that. Now, if I'm going to look at, just realized those forms are right there, and I don't want to click on those. What time are we at? 8 o'clock. Cool. Or we do one more. So let's do another poll. We'll see if this one has another landslide like last time. So. Don't do that. Move here so I gotta pull this over here. So we have Here. Before I post it, I want to give you guys a link to each one. So if you don't recognize the algorithm, you can at least go look at it quick. These in Zoom chat. There's one. The other. So in the Zoom chat, there are the two algorithms that are on this poll. Take like 5 minutes, go look at them quick, and then pick the one you want to look at. Hey, I can tell you right now, it's not going to be a shutout. I think there's only 7 people voting. Oh no, there's 12 people that have voted. Oh, there could actually be a tie on this. Great. Could end up being a tie. That's just what I need. This will just do a coin flip. Every time. Oh, great. 2 more people. On 2 people. That technically locks it in. I will let the last person vote if they want. I'll give you 20 seconds to vote. That'll give us a minute 30 total. So, who hasn't voted? I'm gonna have to check on this because I need to find out from Zoom if there's a way for me to find out who has and hasn't voted on a poll. I do not like when people decide not to vote. If you voted, please do a raise hand or a check mark yes. If you voted, do a check mark yes or something. Whoever doesn't, it tells me they're not at their computer.
What if we don't have an opinion on this?
Pick one.
I mean, like I've completed both of them, and
Oh, you
I
completed
don't
them.
know. Like,
Come on, get out there, rock the vote. Let's go.
I don't
What's
know.
more
Okay.
interesting
Do I
to you? Let's put it that
pick the
way.
one I think would be better to explain to others, like more complicated, or
Yeah, but again, you just try if you think that one might benefit you more and just have a class on it, talk about the discussion, you can pick that one. But at least you let me know that, then I won't blame you for not voting on that one as much. Yeah, if you think there's one that you think might benefit the students more, then vote on that one.
okay.
Are you gonna vote or did you vote?
I did.
Oh, you did. Okay, so that you weren't the one who didn't. I think it was David. David, you didn't vote, did you? Probably David. He might have stepped away for work. All right, that's fine then. We'll end it there. And share results. I hate that I have to hit another button to share them. So Sherlock
I
won,
was having a
not by
problem
much.
with my mute.
No worries. So Sherlock won just barely. So if we can get through the tips enough, I may even do a couple tips on climbing the leaderboard. Some people did want it. It's before you wanted it. So I am not opposed to that. It wasn't a shutout like last time. So stop sharing. Let's go to this one. Over. All right. So since you guys voted on this, I did give you the links to them, so you could read it, or you did read it, but just confirm again, 2 strings are anagrams of each other if the letters of one string can be rearranged to form the other string. So given a string, find the number of pairs of substrings of the string that are anagrams of each other. So yeah, mom, so the list of anagram sets are M and M, M-O, O-M, respectively. See how that kind of works. The one's a little tricky. So a little bit. This is another medium one. You guys always pick up the difficult ones. So yeah, number of unordered anagramic pairs of substrings is S. The first line contains an integer Q. The number of queries each of the next Q lines contain strings S to analyze. Yeah, Q10 length of A less than 100. S contains only lowercase letters in the range of ASCII. So the sample output of O, you have A, B, B, A, B, C, and D. list of all anagram pairs is A and A, AB, BA. We got B and B and ABBA, BA at the positions. 0, 3, 0, 1, 2, 3, 1, 2. Those, respectively. No anagrammatic pairs exist in the second grade as no character repeats. So you have that. So another one. I fail. And then 4Ks. 3 and 10 of that. So for the first query, we have the anagram pairs II, QQ, IFA, and FAI. Wait, what? All right, shuffled. I'm thinking, for some reason, I thought pentagram, the flipping ABBA, baby and, not baby, ABBA. I thought ABBA. ABA, ABA. No, not that. So not reversed. So yeah, IFA and FAI. So these three characters contain the same characters.
Well, it's different just leading up to I in that case.
Sorry, what?
They're just sandwiched between two different I's. They're just broken up leading to that character.
Yeah. Right here and
Yeah.
right here. So yeah, we got 6 anagrams of the form KK, 3 anagrams of the form double K, and 1 anagram of the form triple K. CD, we have 2 CCs, 2 DDs, so 1 and 1. We then have 3 of the CD, DCD, DC, and that's, I think, 2. Fun stuff, right? I think. So, any thoughts from people first? People will kind of open the floor first before I do anything. Any thoughts? Really? Didn't anyone even attempt this yet, really? Or have
I-
any idea of a
A
solution?
while
My-
ago.
yeah,
Did,
I
but
mean,
my
Really?
code's awful.
Yeah, my initial instinct was to go for like a frequency hash map,
Mhm.
but I didn't get very far with it yet.
Yeah.
Me neither.
I do remember explaining part of my solution to you at one point.
You
Back
did?
when we talked. Yeah, we talked about this originally, and I had mentioned something about it. I just remember talking
Yes.
about it.
It does seem familiar, but I can't remember at all what you said, what we talked about now. For some reason, my brain is just fried.
I mean, yeah, this was
Yeah.
from a decent bit ago, over a month.
Yep.
This was February 8th, so
So now I'm kind of trying to remember it now myself. Things that when I usually assign you these, I do attempt to solve them myself for some of them. So I gotta look at it from a fresh standpoint, so. Frequencies is definitely something that comes to mind myself, because that's pretty much how I would be able to evaluate that certain sections contain the same items. So the only reason why I would know that this and this are anagrams of each other is because in this block right here, I would have 1I, 1F, 1A, and this block I would have the same scenario, right? So I would need to know that. The current problem I have in my head is that, how do I word this? I don't like the solution that pops in my head right now, a very brute force approach. Does that make sense? Because I would have to go through each array one by one to check for scenarios. So in this case, you're seeing I would have to go through the array multiple times just to get all of this. So remember that. As first, I would go through to find all the single anagram connections. So I would start here and do, oh, there's a K. And then I would go through and be like, all right, well, there's another K, there's a K, there's a K. Cool, I got that. I got all the lengths of 1. So I looked at all the ones, and so I got 3 right there. Then I would do K here, and then 1, 2, there's 3, there's 2 more. And then I would look at the third K and look here, and there is my one more for a total of 6 single anagrams. That would fit this guy right here. The next approach would then be to bundle them into pairs of 2s and look for that. So then I would say, okay, we're looking at this array. I would have a frequency mapping of K2. Looking at this array would give me an array mapping of K2. There's another one. There's one of that. And, oh wait, I forgot, sorry. When I bracket this off, it doesn't actually prevent this one. So then I would have another bracket array here. That would give me 1. Then I would have to move that bracket array over 1 to there. Sorry, let me make it bigger. K, 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 K. So the first time through, I would make a single bracket and then move one bracket, one bracket, one bracket, move that bracket, 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 move that bracket, bracket. So there's my 6. Second time through, I make a 2-dimensional array starting at index 0, then make a second 2-dimensional array starting at index 1, do the frequency mapping on both and find out that they are the same, they work. I would move it over 1, that would give me 2 right there. I would then move the 2-dimensional array over once, start here. I then start the comparator, 1 index over right here, and that would give me 1 more. There's my 3 2-dimensional arrays. See how that's working? And then 3-dimensional array, I only have 1 of them because my first one would be, I would start right here, get the frequency mapping. I would move 1 over to start another 3-dimensional array. Frequency mapping, they match. There's my 1 3-dimensional anagram. Do we see though why I don't like this? Up to my head. Like I can see how I could solve them, but can we kind of see how that can get very long and very crazy, right? Starting to see that? Hopefully. We do have the one thing we can start off with. Is there a quick base case to eliminate something? There wasn't an example where they were able to eliminate something for some reason.
If none of the characters occur more than once.
Sure. So if we do go through and create a frequency map where there's no duplicates of any kind, we can instantly kill it. So 0 there. A, B, C, T. So all these result in 1, 1, 1, 1. We can't do any sort of frequency mapping of any kind. We can't do any anagrams because we do need at least 1 pair to start making anagrams, right? So worst case scenario again, you could always do the brute force, what I just showed there. Making arrays, starting at a single dimensional array, move forward. However, I do feel like there's a better one. Right here, I would want to find out if there's some way I could take a 4 and turn that into 10. Could I figure out how to do that? I do want to start there because my biggest issue for me is the single dimension arrays. Those 3 take the longest. And if I can find a way to maybe mathematically prove those, maybe with the frequency map, maybe I could find some more, right? Maybe it's not going to help me, but at least first scenario, I can eliminate all the 1-dimensional arrays, right? At minimum, I can eliminate that step in my program. Because that is I can already imagine that's going to be a huge choke point for large ones, right? Is that a safe statement to say?
Yeah.
What do you think? Yeah. Okay. So that's my first step. I want to try to eliminate that. So let's think for a couple seconds. So if we have the 2 Ks, how many anagrams do I have there?
Three.
1.
1, right?
2,
Yeah.
4.
I have 1 here. Bracket, bracket. And once if I enclose the whole thing, I can't make an anagram out of it because I can't move it in.
You have
There's no
6.
substrates. So out of 2 Ks, I only have 1 anagram. If I add a 3rd K, how many anagrams do I have now?
Isn't that still one?
No, because I have KK here, then this K right here.
All right, that's using the
That's
multiple.
one right there.
That's right.
Then I have this one, this pair right here. 2. I'll use tick marks to keep track of them. Then, damn it, can't do that. Nope, I went 2. Dang it. Ah. There you go. Then I start here and here for a third one. And that's just my single dimension Ks, right? I also have this and this for 4, total of 4 anagrams. So adding 1 K gave me 3 new anagrams. I'm already holding a cache thing, so that might be something we do. Who knows? Screw it. Let's look back and see if we can reuse our caching system a little bit. So if I have a single K, how many anagrams do I have?
Single K, that's 0, isn't it?
Yep, 0. 2 Ks, we have 1. 3 Ks, I have 4. I don't know how I wrote that so bad. Jesus. So, 0, 1, 4. Let's add, and then we already know the answer to this one, but if I add the 4th K here, what do I get?
Just 6.
The example on the left-hand side.
10.
Yeah, see? 4K, 4K. 10. So we got to our 4Ks, we got our 10 there. How do we go? So that went 6 up. So it added 6. So that went from 0 to 1. We added 1. Added 3. We added 6. No, I'm not seeing a pattern yet. So now there's some scenarios here. We can try to think of like, do I do more like just testing here? Or should I add another one to see if there's one more pattern? Let's try. Add a 5th K. I'm going to challenge you guys to then try to figure out how many anagrams are there here. Actually, hold on, before I do that, let me think for a second. K is made up of, if I think about it, 2 3s, right? It's a K here and a K here, right? Well, those are going to be 4 each, right? 4 and 4, that's 8. Now I just got to do, I think, add more to my 2 and 1, right? How many more 2 arrays are there?
2.
2 additional arrays, right?
Yeah.
Yeah. So it was 4 plus 1 plus 1. Additional, 2 more additional 1 arrays. Sorry, 2 arrays. So 2 more of these. 2 of these and then 2 additional of these that are not inside of a 3. How do you find those? Could you teach computer how to know that?
Say no. I'm feeling dumber than the computer right now.
It's a tricky one, huh? 1, 2, 4 Ks. Move those out of the way. Okay. What I'm trying to do is trying to see if I can reuse my history on this. So we know that there is the 3K here, and there's a 3K here. Those are 4 each. And there's 4 inside of that, in each one of those. That gives a total of 8. There's got to be
So you
something
only
else
need
in there.
2 more.
Yeah, we need 2 more, but that's what we need to find. Are there anything in here that's not included in that we can keep track of? That the 2 3s don't find? Is there an array, a kind these two can't find, or these two can't handle. That's what I'm trying to figure out in my head too. I'm expecting there to be 2 of these arrays. So that's what I'm looking for now. If I need 2 more points, I need 2 two-dimensional arrays. Can I find that though? I'm not sure if I can. So I'm not sure right now if this is working in the top of my head. I'm not liking it because it's not really showing me anything that I want to see yet. And 3 is 4, 2 is 1. Doesn't match up there. You know, we can just use a K and see if we can figure out what the result here would be. Just to see if we can find a pattern. So 1, 2, 3, 4. 1, 2, 3. 2, 1. 10 on the single. That group jumped by a lot already. Just by that alone, we already have 10. I just noticed this is not factorial, but it's the adding of all the numbers. So it's 5. So the single dimensions. Well, that doesn't really help us out, does it? 2 plus 1, yeah. 4 plus 3 plus 2 plus. Wait, what? Hold on.
That is 10.
Wait.
4 plus 3 is 7. And then 2
3.
and 1 is 3. That's 10.
So I'm starting to wonder though, did I just find a pattern in my head itself? No, I don't think I did. I don't know yet. No, 3 plus 2 plus 1, no. Oh, wait, hold on.
I think you're like
Yeah, it seems
adding
like it's
to
the,
like
it's the
an
sum.
increment or
It does look like it's the sum of all the
It
previous.
does, it's not quite, because yeah, the 4, 3, 4, 5,
Well, the sum of all the
6.
previous differences. So after 10, it goes to 20, which is the difference of 10. 1 plus 3 plus 6 is 10.
Yeah,
But after that, I don't.
can you figure out what, yeah, we, without knowing what the next number is, we wouldn't know this number. So I don't know what this number would be here to get me the next number. I need to get to here somehow knowing that it's supposed to be 6 away. I don't know how to get this number. 3 plus 4 doesn't work. 5, 6. 3, 4, 5, 6. So that gave me this. Adding these 3 together gave me that. Give me, wait, hold on. Wait a minute. 3, 4, 5, 6. 2 plus 1 is 3. That's 1. So well, let's find out. Three. 4. 2. 2. Right. Okay. 2, 3. 3 out of the 2 dimension of the first index. Okay. Now, move that over 1. 2. 2. Looks like that's going to be correct. There's a pattern again right there. Right now, I don't like this because it's only with the same character. But least if we get the frequency map of each character, we can then figure out this number at least. We'll have to figure out the larger ones later. But let's figure this out. 3, 2, 1, 2. What am I doing? I don't know why I didn't do the 3 already. I have to do this, sorry. There's my 1. So 6. Now we can go to the 3-dimensional. One and 2. That's 1, 3. I can already just, and again, for anyone who's not sure, I can already see it because I did that one. If I move the 3-dimensional array over once here, I then get one more array right there. So I only get 1. So that's how that one worked. Then I do a 4-dimensional array, 4, 4. That hits 1 item, so 1. So 10 plus 6 plus 3 plus 1. I'm starting to see a pattern there. There's a pattern right there. You wouldn't know this. 6, 7, 8, 9, 10. So 20. Yeah, you're right. It is 20. How did you know it was 20? Did you actually count them all out?
No, I ran it through my program.
Oh.
I ran
No.
it all the way up to 10Ks.
4, 5, 6, 7, 8, 9, 10. Holy crap, that worked though. 4, 5, 6, 7, 8, 9, 10. That's 10. So now I'm going to test something. I'm not going to do the actual long sum. I'm going to do number 6. And you can tell me if it's right or not by just doing my math right here. So my assumption is that to get the next number, we I'll have that here. Be 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's 15 should be 35. Is that correct, Connor?
35? Yeah, that's correct.
I think I found a pattern. Does anyone see the pattern? What I found? So to the total, we add the sum of the digits before. So to get the result number 2, we add 1 to 0. To get number 3, we add to the 1 the sum of 1, 2, of 2, 3. We add the 3. These two added together. And then we add that here. To get the number of anagrams in 4 of the same letter, we do 4 plus 1, 2, 3, 4, 5, 6. There's my 6. 5. We get 4, 5, 6, 7, 8, 9, 10. 10 right there. To get the total of 6, we get 5. We do take the total number of 5, 20, and add to it 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We get 15. These are all getting added up. These numbers are all getting added up. So that tells me the next one, just again, to be a sanity check, 15 plus 6 is 21. Give me 56 for an array of 7 of the same characters in a row. What I like about this figures out all the arrays with the same exact characters. All right, that's not very likely, is it? Somehow we have to convert this or turn this into something that can solve these as well. Oh, geez. Any ideas for an approach? So I don't have anything in my back of my, so I actually got a mint from this one. I don't think, did I assign this one?
Yes.
Yeah, you did.
Did?
Yes. You
February.
actually assigned 2 of them together. You assigned Sherlock and the one before it at the same time.
And
It
the
was
leaderboard, yeah.
Migratory Birds, Jumping on Clouds, Remastered,
I thought that,
and
yeah, there were
Sherlock
3 of them
Anagrams.
together.
I've given you guys the wrong Sherlock challenge. I don't remember this one.
That would make
I
me
think
feel a lot better about it because I really hated this one and
Yeah,
didn't solve it.
I think I gave you guys the
We
wrong
learned
Sherlock one.
while attempting a few things. So.
Yeah, I think I'm gonna give you guys the wrong Sherlock one because I don't actually have prior experience on this one. So I know I have a solution for these guys. So I can figure out the number of anagrams in a array and a string of all the same character. Yay! It doesn't really help us yet. The benefit of this though is that in the very first item, the minimum I can do right now, of course, is in this guy right here. When I do the frequency map, I of 2, F of 1, A of 1, L of 1, right? What other characters are twice? So U of 1, right? H of 1, K of 1, and Q of 2. I right from the get-go on this, at least, can say I have 1 anagram of I and 1 anagram of Q. So I can pull those out right away. Now somehow though I would need to find, so now the big challenge for myself is how do I find this, right? Wait a minute. I have a thought. Can anyone see anything else? So what I need to know is because I have this I, there's 2 of them and there's other characters in between. I know that if I can at least anything between my I up to but not including the second I, and then that I back to but not including that first I is an anagram, correct? So let me make this bigger again. So I, F, A, I, L, U, H, K, Q, Q. Because I have 2 I's, I know that from the I up to, but not including the I, and then from this I down to, but not including the I is an anagram, correct? Is that a valid statement?
Well, no, because doesn't an anagram count as it being in there more than once?
It's right here, actually, sorry. Anagram are just the same characters that can be
backwards.
readjusted, not backwards. You're thinking of parallelogram, I think it's called.
No, I'm saying on the bottom there, it's IFA, and then in the bottom it's, no, it's not backwards.
IAF.
Yeah, the print is really small.
Yeah. Yeah, no, it's not the same forward and backwards. That's not the one we're looking for. We're not looking for the same forward and backwards. We're not looking for something like ABBA, that when you reverse it, you get the same thing. We're not looking for one of those.
I think you were thinking of palindrome, Cliff.
Palindrome, thank you, that's the word. Yeah, we're not looking for
Parallelograms of
palindrome,
shape.
which I believe that's the first one I was looking for. I think the first Sherlock, or one of the Sherlocks I did was palindrome finder, which is easier. I can't, this is a statement I can make that, yeah, the I up to, but not including the I, and then that I down to, but not including the original, the first I, those are going to contain the same characters, right?
Correct.
That is safe to say.
Mhm.
And so that way I can, so that tells, that can find me a anagram. And since I know there's only one of each of those, so then I can say, okay, well now I definitely found an anagram. So I can, since I know there's an I, I'm going to find the first I, and I'm going to go up to until I find the next I and make a substring of that. So I, F, A. That's my item. And I know that there's one of those. So I found one. So that's an anagram because I got the IFA and the IAF. What I can do, of course, I can then search and see if there's, and I can also check here to see if there is there another F and is there another A? Because what if I had, instead of this, say I had, dang it. F, I guess. That would do IFA, IFA, IAF. And that would give me a second one, wouldn't it? Yeah. But that way I can then search for the A and the F somewhere else, if it's next to the I, right? I can then pull the same length next to this I and see if that has the same frequency mapping, right? So I can do that. That's not a possibility. So main thing is I was able to find the other one if I could do this. I could also do the same thing with the Q. The Q up to but not including the Q. Is there anything there? Or is it just Q to Q, right?
Yeah, it's Q to Q.
So there is no Q-based anagram that contains some characters, right? Now, none of these can be part of an anagram. None of these other characters, the F and the A can't, and none of these can be part of it because there's no repeaters. We've learned that from our previous solution, right? That if there's no repetition, those items can't be part of an anagram by themselves. They need to be included with some sort of replicative. I think I might have found something there. I think I might have found something. I don't know if this will solve all anagrams yet, but once you do the mapping structure, once you do a frequency map, you use this algorithm right here for these guys. Yeah. The downside though is that later on, if I was to add a Q here, that shouldn't mimic this perfectly because yeah, that's not going to match up right. So that's something we got to figure out later, whether they're bundles. Dang it. Yeah, you only need to do that for a bundle of them. Which I guess we could find out. Yeah, that's actually, I know this still can work. So first off, find them all. And then for every instance of them, you do that -1, right? I think. You think? Ooh, not? I something I 3 I's. How many anagrams is that? Is that 2 anagrams or 3 anagrams? So I'm picturing it like these two, and these two. Is that true?
Yeah.
There's 3 of them. I something, I something, I something, I. 1, 2, 3. You. Oh, good, differently. You. 1, 2, 3, 4, 5, 6. There's a little more we need. Little more, not much. Because I realize this calculation is for if you had them all in a row, which is important. Because if we then started doing this, we do need this math, right? For the Qs. But we need a different math when we have variables that are not bundled, correct? So those are 3 items that I can think of that I would need to polish off. So let me just refresh them again. So we have our bundling algorithm, which is, I don't know if I want to give you that yet. You might want to take a picture of this, but it's the result of 5 is the result of 4 plus, it's not the factorial of, what is the, when you sum up all the previous numbers? You know that terminology? I can't remember the math term for that.
Was it sum and then divide by the number of those numbers?
No, it's this one. So to get the number 5, it's the total, it's the result of 4 plus 4 plus 3 plus 2 plus 1. Don't know how to, I don't remember what that's called. Because I know that factorial of 4 is 4 times 3 times 2 times 1. But I want plus, not times.
Oh, yeah.
Anyone know what that's called?
I mean, that's just
Not
like
off the top
that's
of my head, I
that's
don't.
just the Fibonacci sequence, but like I don't know if there's a term.
It's not
for that.
Fibonacci.
I mean, that's pretty much what it is. What you're doing with Fibonacci is you're adding the previous.
Kind
But
of, yeah.
This has something to do with like triangles.
I don't know what it's called. It's annoying me because it's a math. I'm sure there's a name for it. I just don't know what it's called.
Is that the
Result
Gauss
of-
formula?
Is that Gauss? What is Gauss? Someone check that. Get what Gauss is. So
Triangle sequence.
So anagram of five of a bundled anagram of five. So here we go. Hold on, let me just make sure this is right. Bang of five. So a bundled anagram of five. So 5 characters of the same letter, same character, is equal to the bang of 4 plus what's called sum of 4. So 4 plus 3 plus 2 plus 1. Whatever this is called. Whatever this is
I mean,
called.
do you want the official term? It's the it's the nth triangular number.
Ugh, great.
Just rolls right off the tongue.
They probably represent it like this plus 4 that.
It's just represented with the summation one where it's just the sigma character.
Oh, that thing, yeah. I
Yeah,
should have thought of that.
It's just n over sigma over k equals
Oh,
1.
what's sigma? How do I write sigma again? I know
It's like
in
an
my
E,
head.
but like really weird looking.
It's arrowed E,
Yeah, pretty much.
but I'm doing it wrong somehow.
Yeah,
I
the
don't
top
know how I'm
part you
doing it
put an
wrong.
extra line on, but yeah, it's literally just like an angular looking E.
Really? Oh, that way.
Yeah.
That's what I'm doing wrong. Okay, hold on. Back to here. Sigma. Plus 4 sigma. There you go. That's your algorithm. So bang of n is bang. I love it, actually. So bundled anagram of n is the bundled anagram of n minus 1 n minus 1 plus n minus 1 sigma. So we do have that. So whenever we have an n number of characters in a row, we want to use this guy. Make sense? All right, know that now. And then we need another algorithm for determining the number of singular anagrams when they're not bundled. So that was, so if we have 2 that are not bundled, we get 1. If we have 3 that are not bundled, we have 3. I think that's going to be just the sum, isn't it? 1 plus 2 plus 1. 3 is 2 plus 1. Yeah, I think that might be it. It's 1, 2, 3. We have 4 not bundled. 2 plus 1. We have 4 unbundled. We have 1, 2, 3, 4, 5, 6. 3, yeah, maybe 3 sigma, I think. Right? 3, 4, 5, 6. Yeah. There's gonna be 2 sigma. 2, 3, yep. That is 1 sigma, which is 1. I think that's right. What is it? How's that looking? It looks like it might be the sigma if you got the ones unbundled. So that's why we got this one as a 1, because they're not bundled. It's just sigma of 1. But if I added in, let's just for the fun of it, added a Q here. That'll give us a total of 3. 3 Qs. I think 2 side by side, we don't consider that bundled, I'm thinking. Probably. Even though, if it was though, it would still give us the 1. So it's going to be treated as unbundled, I guess. I feel like I'm not sure about you guys, but how close do you think we're getting? I feel like there's a lot going on. I feel bad that I'm kind of walking through this. I'm not sure how to make sure you're kind of pushing forward. Are we seeing what I'm doing, at least?
Sort of.
Yeah, somewhat.
Pretty lost here.
Hard to say. It's hard to keep track of how to walk through a thought process. I'm not sure if I'm speaking everything out loud, and you guys aren't seeing what you can't see where my eyes are looking. So that you don't know exactly what I'm looking at and how I'm looking until I write it. And so it's a little difficult. The main thing is I'm just trying to, for this one, the biggest problem for me is just trying to find ways that I don't have to iterate through this array multiple times. I want the data to tell me what I should look for. So the frequency map is key, because that'll tell me, first off, can I find anagrams? Once I then find items that are repetitive, I can then use that to find additional anagrams. So this right here tells me to look here and here. If there was another I, let's say, we'll get rid of that K, put the I here, this would tell me that there's multiple anagrams again from here to here, then here to here, as well as from here to here and here to here. So that would help me to find additional anagrams, because everything in between those two items is an anagram. Do you see how that works? So I'm using the frequency mappings to tell me what to look for. What I'm trying to do now is just try to find out, can I make math from this original frequency mapping? And the only way to know for sure, can this math work, since I'm not a mathematician, is to just test it by just viewing it, just looking through and just writing numbers out. Does that make sense? Main thing for me is that I have a lot of practice, and I think this is my thing exactly. I have a lot of practice in looking for patterns. I like finding patterns. It is something I kind of enjoy doing, and trying to find visual representation of things I'm trying to do. I'm very, very visual. Why I tend to prefer videos over books. My key technique, and one of the things I do need to work more on is, and this is my thing, that I need to do more on, is not needing to do as much drawing and writing to find a solution. And that's my next stage for being a better developer, is if I don't need to do as much of these because I have more past. Since in this one, I have nothing in my past that is kind of triggering for me, that I haven't solved an algorithm that is in any way similar to this. I have no history to pull from. And so for me, I have to do a lot more just trial and error, playing around with the data, manipulating of the data, massaging the data until I can see something that I can work with. Does that make sense?
Mm-hmm.
And that's what I'm trying to do here. I'm trying to manipulate the data and play with the things in a way to see what I can find and to look for patterns that I can then abuse. To put it simple. I'm looking for data to abuse. I at least found this one, but I'm not sure 100% if I need it, because again, trying to figure out where the bundles are and if the bundle is necessary, I haven't decided on that yet. If that's a needed item, something I need to look into as I move forward. Because later on, what I could end up doing is just, finding out later that, oh, once I find the right quantities, I can still run the math and still find it. So I need to run more calculation on this just to see, can I do it? Because maybe this one right here, maybe I already found it. Maybe it's the sigma system on this. Because we know we have the one here, and then because it's two here, we definitely add the one more because they're not bundled. So just check to see if these are bundled. They're not. All right, that adds one more. But I need to find out more on that and confirm more on that and do more math. When would I write code though? I tend to write code once I'm pretty confident I have something basic. Another thing I might look at again is just going back to the basics. And like I said, trying to look at it from a smaller sense. Instead of looking at the bigger arrays, start with the smaller ones, and can I do something memorization again? Can I utilize that kind of stuff? Can I, as I go through the array, I don't want to have to go through multiple times. That's my biggest thing here. I don't want to have to go through the array multiple times. Why not?
As unnecessary complexity.
Right, it adds exponential dependency. Every time I got to go through that array, especially with nested items, it's exponential growth. So my goal is to try to go through the array once or twice. That's fine. Going through the array once or twice, doing a second pass over, that's fine because that adds multiplicative growth. Multiplicative growth still isn't good, but it's way better than exponential growth. Exponential growth is the thing you want to avoid the most. That's the thing you need to avoid. And the first brute force way of approaching this with the multiple brackets is a exponential way of approaching it. So I have a nested for loop touching every element multiple times as I go through. So my goal, of course, would be to try to figure out, can I get a frequency map and using that frequency map, determine the number? Does that make sense? For me, it's more just, I know that a brute force is never going to solve it. Now in an interview, I may just code the brute force after a while. That makes sense? I may just end up coding the brute force because I need to solve some test cases. And I know that a brute force will at least solve some, correct? And so that would be the first thing I would say. Perfectly fine with that. Connor, if you had to try to describe your current approach to this, so you said you ran something through yours. What was your current approach?
Our approach is fairly brute force. It's iterating through the array multiple times essentially, or it's iterating through an array multiple times to match everyone. I pretty much just brute force right through. I'm currently just making another much simpler version using like a hash map and doing frequency stuff.
Yep.
Taking part of what I did before, but this was a mess.
This one's tricky because again, it also is just multiple ways of approaching it.
Oh yeah.
You could also just create a hash map of frequencies. So you can know that there are what kind of like substrings and stuff. So you can create the substrings that have your frequency mappings. You can try to find those and then determine how many replicate them. Because then of course, like I said, yeah. I lost my annotations. Oh, I didn't mean to get rid of that, but like create a collection of substrings, so just a bunch of substrings. So you just create a bunch of substrings of just what possibilities there are. So then you can compare them with frequency maps. So the problem is just, yeah, memory on this could be massive if you're not careful with that. And then you have IF, yeah, and we have all of the possibilities in that, and you'll see how crazy this can get over time. I have 1, I have F, which is F of 1, et cetera. And then I have IF, which is a frequency mapping of I1, F1, et cetera, et cetera. That can get a bit crazy. But again, that would allow me to then check for potential anagrams. If two keys have the same frequency mapping, they're anagram, right? So there's a bunch of different ways to approach this. The trick again is those, what do you see? in a lot of anagram and a lot of algorithms, it's what patterns, what process can you find? And a big tool of it is based on what have you done in the past and what algorithms do you know, what process, what methods do you know. I'm going to do a little more research in my head to figure out, and a little more playing around to figure out what algorithmic approach fits this problem. And apparently my understanding though is that I have not, I have no exposure to an approach or data structure that fits this problem. And I've solved a lot of algorithms, but I haven't solved them all. Straight up, there could be an algorithm you're going to get that you won't know the solution to right away, and you won't know an approach off the top of your head that's going to make it quick and easy. Once I remembered about the bottom-up approach for the previous algorithm, I found an easier solution to that. I know there's one for this. There is an approach to this. There is a algorithmic approach or algorithmic concept or process that can be applied to this that will find it. It's just not clicking in my head. And I'm actually not sure if I've even found one for this before. So I will do a little more research. And that's one of the things I do want to do on these algorithm days. I would have been able to look up a approach to help instruct you guys on, because I want to introduce you to those approaches if you guys submit these before algorithm day. So it's very important that you try to submit these before algorithm day, so I can do the, I can actually pick the one that will allow us to introduce a new approach or process or concept of algorithms to help you solve more. I don't like doing this, where we're trying to have me approach a problem and solve and kind of come up with an approach on the spot, because that's not really a great lesson in my mind. At least for me. If you guys like watching me kind of do this stuff so you can see how you can do that stuff, go for it. But I feel like I'm just losing some of you when I do this. It's like I said, if it was in person, it'd be different, because I could point at stuff, you could see what I'm looking at. You guys could come up and kind of point at things yourself and do things like when I used to do these things back in Niantic, it was different to be able to do this kind of stuff with the class, because then you can see better what I'm looking at, what I'm browsing, and you could also contribute a bit better, right? This doesn't work as well remotely doing this. So what I want to do instead is make sure that we have these submitted beforehand so that I can then turn it into a lesson and instruct you or showcase a concept or approach to problem solving, to algorithms. Does that sound better? I'm concerned that I might have lost some of you with this. Some of you just saw this as, I can't solve algorithms.
Not at all. I'm lost on the math part of it, but I kind of followed where you were trying to go with it.
Okay, good. That feels a little better. I was getting concerned.
Yeah, there's always going to be algorithms you can't solve.
Yeah, they're going to be, and solving those with people watching can be tricky, because again, I now have to try to explain as I go what I'm thinking of, and so it slows me down, and I can't think as fast as I would, and I can't, and sometimes my brain isn't allowed to wander as much as it would on my own too. I definitely solve algorithms a bit better when I have a couple minutes of silence to really just process and just think in my head and just draw randomly without having to worry. Am I drawing in a way that you guys can follow? Am I explaining what I'm doing in a way that you can follow?
So I think that this actually helps because it kind of gives us perspective. Again, I can only speak for myself. It gives perspective on you being able to solve something on the spot. Because I feel like for a lot of us, if you gave us a couple of weeks, I'm sure we could probably figure this out and brute force our way through. This shows an approach to something where it is kind of timed, because you kind of are timed.
Yeah.
You had a half hour to do this.
Yeah, that took an hour.
All right.
You did say you were gonna get off at like 8, and it is 9.
I thought it was going to go up to 8:30. It's now
to
9.
be fair, though,
8:30.
you did say the other day that technically you did this in a half hour because it took you an extra half hour to explain every step.
Yeah.
So you did actually do it in a half hour.
Yeah. I definitely feel like I could have gotten to this point a little quicker if I wasn't walking people through it. Yeah. Could I have solved this one in an hour? I don't know. This is a trick. This one right here is tricky. This one is very tricky because of like the amount of variety in it and the amount of repetition and just I hate overlap stuff. Overlap stuff is one of the things that I haven't really mastered in algorithms yet myself. So when you see items that have to worry about overlapping for collections,
Would it be better if we had just let you solve it and then explain afterwards? Like give you a couple of minutes to go through, run through it. All right, this is how I'm going to solve it. Blah blah
Well,
blah.
that's-
We'll
yeah.
just sit here and watch your approach, and then afterwards you go in and okay. So at this part I was doing this, and at this part I was doing this, because then it's already done.
What's
Now
the
you can-
point of the form?
we could, yeah, that's the point. That's what I would like to do with it, and that's what I'm thinking of. If you guys can submit the algorithms earlier, because unfortunately I got these submitted today. These two algorithm, this algorithm and the claiming the leaderboard one was submitted to the form today. So I didn't have time to look at this beforehand and to come up with an approach that I can then teach. That makes sense. Same with last week's too. The algorithms last week were given to me on that day. So again, I didn't have time to approach them and come up with a lesson on
I'm a
how
fan
to
of
approach
either.
it. What's that?
Because I said I'm a fan of either. I mean, planned is always. I guess planned is kind of better because it gives you time to break it down into a way we'll understand it. But I'm not gonna lie, I do actually enjoy seeing the idea of, well, I don't know it, so this is how I would approach it.
All right, good to know.
Plus, it kind of humanizes the whole process.
Yeah, it does.
Honestly, like I said, if you gave all of us time, I'm sure with enough time we'd all fix it. I mean, we'd all solve it to some degree.
Yeah, and the let you guys get a little bit more relaxation on this as well. In your interview test, when you finally do go to the interviews, you'll probably get one of these, and the rest will most likely be the easier ones, more the easy level, as well as a slightly harder easy. The ones that are a little more challenging that are marked as easy, but you usually get one of these that are like, okay, they're gonna be a little time consuming. I have to really investigate and dig in and do stuff like this, where you're gonna get only a portion of the test cases correct. All right. So don't think like when you go for the interview, all of them are going to be like this, that you have an hour and a half to solve like 4 of these. That's not going to be the case. There's usually one challenging, difficult one. There's one in there that is a trick that seems difficult when you first read it because they're kind of misleading in the details. So the goal there again is to just read it without reading the story and to just understand the basis of the problem. And that was one of the things I kind of wanted to do, like I said, with the previous one, was just kind of showcase that if you stepped away from knowing which houses specifically you robbed and just kind of keep track of the optimal solution or the optimal scenario or the optimal system, that's going to get you what you want. You'll get one of those items where, yeah, the solution, if you look at it right, will be like, oh, there it is. Okay, found it, done. 5 lines of code, so solved. But the problem itself is so wordy that you think it's a challenging problem. So there's usually one of those in your interview challenge, where the solution, 5 lines. The problem though is like 2 paragraphs long of like story. So be ready for that one. And then you'll get a bunch of easier ones that are just there just to test your basics, test your fundamentals. I need to go take a nap now. I'm lightheaded. I wasn't feeling good anyway. Yeah, you weren't even here, David. I wasn't feeling good today.
Oh no.
I'm feeling a bit under the weather the last 2 days, so.
Oh boy.
I'm now drained. Oh boy. So I'm gonna go upload this video and then probably go take a nap.
Yeah.
Sleep.
Don't forget the other 2.
Those are uploaded.
Last
I did
week?
get those
Okay.
uploaded. Yeah, I did that this morning when I woke up and I was feeling at least functional. I was feeling like I could do stuff, so I got out. I pretty much rested most of the morning, and then I got up and like I'm feeling human. I'm gonna finally go upload what Leah told me to do yesterday. So got those uploaded. Those are there. I'll try to get this one up tonight before I go to bed. So I'll just rest for a bit, upload it, and then head to bed. All right. Any quick questions on anything?
Nope, no questions. Go to sleep.
Okay. Well, I'm gonna ask you guys, so again, I might try to put out a ping on Slack on Saturday or Sunday to submit algorithms for Monday now, instead of waiting till Monday, have you guys submit them. I might ask you guys to submit some I'll do a reminder on Sunday to submit them if you don't already have them submitted. And then, yeah, and that way at the start of class, I can also give you guys those algorithms. You can take a look at them, try them yourself, and attempt them yourself too. And then we'll come back and we'll kind of look at them together. Does that sound good? Next Monday? All right, try that for next Monday. Also, I'm going to talk to Arnell. And I got someone did you ask for a way of providing feedback for tutor sessions, which makes sense, but I actually don't run the tutor system. The tutor system is a paid item. I mean, a lot, but it is paid. So Arnell is running that. So I'd prefer to make sure he has access to that form. So I'm going to talk to him about making that so that way it's his form, so that way he gets the feedback. So I think that would run it the best. So that way I'm feeling good this weekend. I really didn't speak to him much, so I hope to speak with him again sometime this week soon. Before, because I did want to talk to him again about the stipend thing, if that's getting renewed at all. But really, my goal for you guys also, I want to talk to him just about when is the next interview process. So before we go, that was the last thing I wanted to get you guys right. Ooh, damn, almost forgot.
Resume template.
Yes, that. So yes, when you are alumni, you're also called the Dragon. That's why we call this the Dragon's Keep. I'll be handing you guys this. Phone number, obviously email, street address, city. We did this, we thought it was obvious, but I've got a couple people asking, so I want to clarify that. Keep these to one line, try to mimic this directly. So what we've gone through with the couple iterations of the cohorts is we found a resume that is ideal for both computer scan systems and the humans themselves. Your resume isn't looked at initially by a human. Your resume, when you submit it, in most situations, about 9 out of 10 times, it is first scanned by a software that grades it and ranks it and decides whether or not to then pass it to a human to read. So before it's even seen by a human, a software scans it and scores it based on certain parameters. This is something we found. But at the same time, we know that some companies don't do that. So we do want to make sure it's at least it is human readable as well. We've gone through, we've kind of tested a bunch of options and found that this format tends to get the best reactions from the hiring agencies and the hiring managers and even the headhunters. So put this on LinkedIn to find it, because I can guarantee a lot of those headhunter people that actually reach out to you, they're actually combing through people's profiles, looking at the resumes. They're also running an application that scans the resumes automatically and says, hey, we found a resume with these keywords, reach out to them. So we've designed this to make sure that you have an opportunity to put multiple keywords multiple times and in different variations. That way, if someone's looking for JavaScript, one word, like they should be, or if they're looking for JavaScript, or they're looking for JS, you'll be able to have an option to put that in 2 locations. So JavaScript here in your skills languages, but in one of the projects, you could call it JS. Put JS as the item here, or put in the JS in the title of the project. So you have JavaScript and JS. You have the 2 ways of triggering the search for that concept. Does that make sense? So you want to also find those multiple different ways of being able to enter the same item. For languages, put any language you've even dabbled in here, because again, your focus is not your language. You're not, even though they are put you in companies that are doing Java, you are not going to avoid a C# company. C# is object oriented, and there's even some Java code can't even be copy pasted from Java into C#. Not all of it, but some of it can be. And that's a big thing there, because I can pretty much guarantee that if you are decent in Java, you could very quickly learn C# enough to go into a C# company. I can also tell you that several of our students that have graduated or got hired based on their Java knowledge, but within a couple months, we're no longer coding Java. Christian, and this was not a program heavy, this is not a programming person. Christian was, this is a different Christian than Christian Pari, but this student knows, Titus, Titus used to call him Cuffy. So this guy, he actually worked at his job when he started going to career devs was at a tea store, a tea shop, whatever you want to call it. He served tea. He was not a programmer. Learned Java, really had fun with it. He was the one, I don't think I mentioned to some of you, he was the one that actually took the Yahtzee application we built in the terminal, and he actually built the scoring system for it on his own time, on his own personal time. So told him to put that in as a resume, on his resume, because it's like, hey, you went above and beyond the project. So at first, when someone looks at it like, why do you put a Yahtzee program on there? It's like, oh, this is one I actually want to, I just had to go above what the class told me. They wanted us to just build a console app to let's roll dice. I just had to add in all the code to add all the scoring system. It's a great story to show that you can sometimes go above and beyond. So it wasn't a complex app, it was a console app, but that concept, that idea of going above and beyond and all the complex code for the scoring system under Yahtzee was just impressive to show off. So, but yeah, he went and got a job at a luxury jet company up in Boston based on his Java skill and started with Java. The company though had right before he was hired, the company had actually hired or contracted a third-party company to build them a extra piece for their system, and they built it in Ruby on Rails and Ruby. And so they asked him if he knew any Ruby or if he was willing to learn it. And they talked about it and like, we need a bug fix. Could you try solving this? Take a look at the Ruby code and see if you can figure it out. Because you don't want to have to pay the third-party company to fix this bug, right? We'd rather have our in-house people work on it. So he went home, he looked up a basic thing on Ruby, ended up fixing it, and they then actually gave him a small promotion, I think an extra like $10,000 or $15,000 a year, and made him the Ruby developer for the company. And then he was the lead developer on the Ruby portion of it. So he started learning it. He then learned Ruby on Rails and dove into Ruby. So you're not, Taylor looks shocked by this.
Take that story. I'll do that. All of that. Wow. That's awesome.
Yeah, and that's one of the main things also we're trying to do here is make sure you know enough about computer science that you could learn another language on your own time after career devs. Yet at the same time, he did ask me for Ruby resources because that was actually the first language I mastered. That was after I did Arnell's course, at the end of it, he actually challenged me to go learn Ruby and build a site in Ruby on Rails. So he actually came back and asked me for some resources. And so I sent him some of my Udemy courses that I had used, some of the articles I had read, and some of the projects I had tried to build. So by all means, once you graduate, if you need something, always feel free to reach out. But that's the thing, don't be bound by your language. Definitely lead with your main language, but if you at least dabbled in a language, write it down. So if you've dabbled at all in another language, put it in. Technologies and frameworks. Go ahead, Taylor.
I'm just gonna iterate on that point so much. From my last career is being a lighting operator for different desks and operate. I might have said this before, but it's the same exact idea. Understand the principles, understand your way of working, understanding how you like to set up your workspace, how you like to solve your algorithms, your programs, because the languages are fairly consistent with the loops and with the conditions and the things we're doing right now. Like from looking at a little bit of Python and other languages, it's just they declare things differently, and just understanding their language, literally their language, most likely you'll be able to do a lot of what you're doing in Java now. It just takes that time of like sitting and understanding what those core concepts are for C, for Python, for Ruby. Because I had to do that in the lighting field of like outdated desks and softwares that were like 20 years old. And I was like, oh, I have to have this done by tomorrow. Great.
Yeah, there you go. Even all this, I'll do another little output on it. I found out this week or this weekend that I've been full-time programming now for 6 years because I got reminded from Google of a picture. The very first time I tried to run my own coding event at Small Point Cafe down in downtown Providence, and nobody showed up until about 5 minutes before I was ready to leave, which was actually about 45 minutes before the meeting was supposed to end, and Arnell walked in. I had actually, the picture was a picture of me kind of trying, you could see the fake forced smile on my face to my ex, of me just being like, yeah, I'm here, but nobody's here, so maybe I'll leave soon. And right after I sent that picture, Arnell popped in, and this guy I didn't really know much yet. And so he sat down, and there's a picture, and I got to find it again, of me holding up my coffee cup and him fake holding up a coffee cup. He didn't have a coffee cup in his hand, but he held his hand up like he had a coffee cup, which is 100% RNL. But that night he gave me a bunch of advice of how to look into code, like how, a lot of research, how to just build things, write code, always code every day, solve algorithms, build things, create things, just keep playing. And then he also offered his house to, which was, or his business, place of business, as the next location for my event, and to do it on a weekend, on Saturday, not Friday. I did, and ended up getting 9 people to show up that time. So I went from nobody showing up to my event to 9 people to show up to my event. And it reinvigorated me and kept me wanting to run my own events. And that was one of the other main things that kind of connected me and Arnell a lot, was the fact that he was running his events and I was running mine. And then I brought a bunch of people who were attending my events to his class. And then I kept running events as just study sessions. And so it really motivated me. And so, yeah, I've been only doing this for 6 years. That's it. But I will say I've probably coded in like 8 or 9 different languages, PHP, C, if you want to argue it, HTML, CSS, you can argue those, I guess, JavaScript, now Java, C#, C, Ruby, a little bit of Python, Solidity, now Haskell. So I'm about 10 languages, around 10 or so languages in multiple frameworks, which takes the language and complicates it and makes it a little more crazy. How would you say that knowing Java means you know Spring Boot? Or would you count Spring Boot as a separate entity?
You asking?
Yeah.
Yes.
I'd say that's separate. Yeah.
Yeah, right. Just because you know Java doesn't mean you're gonna be good or know Spring Boot, right?
Right.
And so, yeah, if you start adding in the frameworks, I'm hitting 20 items. And it's not because and all it is because I understand the core fundamentals of computer science. It's not about the languages. As Taylor said, yeah, it's the languages are very similar and just slight variations. When I go to learn another language, I just need to know how that language handles the same concepts and structures that I'm used to. It's why I'm so able to learn another language so quickly. Why I was able to switch from Java and go to like Haskell for a little while, and go to JavaScript for a little while, and go to C# for a little while. That's one of the big things. And now I'm even dabbling a little bit in Rust, another language. Again, just based on the crypto market, the crypto economy, I'm just dabbling in these languages that are being favored by the financial sector and the crypto sector. And again, while yes, learning the language can be challenging at first, you're really just trying to find how that language handles what you already know. So don't feel like you're bound by the languages you put here. And again, if you at least dabble in it, put it there. Your technologies and frameworks, as you can see here, yeah, CSS, HTML, Spring Boot, Git and GitHub, any of those. Then yeah, personal skills. These are the things that are useful in a professional environment that are not technical. So how are you with teams? Have you done team stuff? What are you interested in? What do you like about that? Even technology related, what do you like that is technology related? So yeah, put in machine learning, even though you haven't dabbled in it, you're fascinated by it and you've at least read articles on it. For your projects, like I said, we want to get at least 4 in here. We're looking for 6 to 10. If you have enough, you can actually do 2 columns. We might even do that. We've done that before, but really, again, this is your priority. This is why we lead with the projects first, because most of you aren't going to have a lot of tech experience here. So focus here with your projects. Again, start putting what you think can go there, even if they're not ready yet. If you want that project on your resume and you think it should go there, put it there for now. So at least we can discuss it later on in a future day. And then for experience, I want to clarify one quick thing. This is not your work history. If you worked a restaurant job for 5 months, I don't want it there unless you change their procedures and help them earn an extra $1,000 in a month or $10,000 in a month. Unless you made a huge financial impact to that restaurant in the 6 months you were there, I don't care about it. This is not your work history. This is your work experience. What we want to put here is the companies that you worked at that you had a huge value additive impact at those companies. And keyword there, huge value added impact. Do not, under any circumstances, just put what you did at the company. If I said, well, at Geek Squad, I was a technical support engineer, what would you say my job requirements were? What was my day-to-day requirements? Can you assume what those were?
Yes.
Yeah, right.
Yep,
I said
clean message
if I said I was
boards.
an automotive engineer at a car dealership, could you take a pretty good guess at what my daily tasks were, right?
Yep.
I don't need that on a resume. What I want to know on your resume is what were the impacts you had at this resume at this company that will last at this company, or what did you do that was impressive? What did you do that really was standout-ish? Did you make any changes to the business that helped them to perform better? Did you change anything? Did you improve anything? Did you get any accolades while you were there? Were you any sort of awards or recognitions of your work there? That's what I want here.
Would
All right.
nonprofit and volunteer also count into that experience?
Oh yeah. Yep. I'll put that, instead of putting it under experience, I put it under personal experience. That's not work experience, it's personal experience. So just make another section here, mimicking this concept, just put personal experience. Yep. Sound good?
Yep.
All right.
Well,
so I'm gonna share this out,
all those jobs you listed though were, engineer or technical. Like, what if you've held nothing but really crappy
Yeah.
jobs and had
Automotive
really-
engineer. Automotive engineer is just a fancy term for just saying a car repairman.
All right.
I repaired cars. That's all I did.
So it's like sandwich artist and
Use
Sanitation
the technical term of the industry. Don't use any fancy terms. But yeah, you can use just line chef or something for like Subway or something. But again, if all you did was just work there and you did your day-to-day job, you went in, you punched in, you punched out, and that was it. I don't want that job on your resume, unless it's a massive gap. If it's massive, then we might have to put it, especially if you want to put the job before it. Really, what if you, while at that job though, if you change their structure in some way, or did something to improve customer satisfaction, or did something to bring in more funding because customers were just being served faster, if you sped up the processes, if you were recognized by the company for being an outstanding seller, an outstanding communicator, for if you were recognized like employee of the month, or rewarded for anything that you've done, won a competition at the company or anything like that. One of the main ways I got out of the food industry, the way I did it was that I can't remember I had my story that when the company did an upsell challenge, and I was the ice cream guy. I did ice cream. I served ice cream to people at the window, but there was a competition to upsell the customers something. The servers had everything from appetizers to onion rings to ice creams to all sorts of things that they could add on to their tickets. All I had as the ice cream dude was nuts. That was my upsell. I could add nuts to an ice cream. But I did it so well that I actually ended up winning at my store. All I had was nuts. And so I used that story that I was able to upsell so well that I got rewarded for that to get a job at a game store, because the game store wanted you to get people to sign up for their membership cards. It was game crazy. So the fact that I was a good upseller, they're like, we want this person on our company because that's what we want them to do. We want them to do exactly that. And so I was able to transition out of the shitty food industry job of ice cream server to video game salesman because of a sales related story that was impactful to the company. I was a top upseller.
Hard skills versus soft skills.
That.
Just a note,
Go for it.
Ocean State PMI loves to talk about like buzzwords that companies are looking for.
Hmm.
So any job you have, you can break down, whatever communication skills you learned, whatever team working skills, and especially stuff whenever you're working with the public, they like to call it emotional intelligence. Now, if you say on your resume that you are an emotionally intelligent person, I'm gonna like laugh at you. If you can talk about how you dealt with like difficult customers, difficult situations, like companies pay attention to stuff like that. Maybe more so in your interview, not necessarily like on a resume, but all of those soft skills are really, really helpful, just a little more difficult to get on your resume, but you can translate all of those shitty jobs into something meaningful.
100%. Yep. Yeah, talk about how you were able to satisfy a unruly customer, or that there was a picky customer that only ever wanted to deal with you, that they liked you, and so they wouldn't deal with anyone else. I had that at the last job I had. That was one of the things I had that I was able to utilize to get when the first time I got up to a raise, I would utilize that to get better than their max raise that they were going to offer people. Because there was one customer that was so annoying to everyone else that when she decided to say, I just want to do with Cliff because he helps me out, he's perfect. He always helps my problem. I was able to utilize that. And then I was one of the few people to actually get assigned to this company. Because they don't do that. They didn't do that at the company. They didn't assign support reps to a customer unless it was necessary. I was so good at helping this customer that they actually assigned me that. And I was a newbie. I was less than a year old. They don't do that. Like, I got this. Like, no, yeah, we took that into consideration. We're actually going to be giving you a raise more than our normal percentage. We're actually we're gonna. You're technically allowed, but try not to tell this to the coworkers because I think they may have pulled some percentages from them to give to you. Like, got it. So I had to keep quiet on it.
So how would you write that? Because I mean, I deal with all the superstars at my job.
Well, that's kind of what you can say. You were, but again, find the right way to say how like you were selected or that you're the go-to person for certain customers. That you're a go-to person. Like I said, leadership. Something that points that you're an outstanding individual, right? Find those items and just explain them matter-of-factly. Don't over-embellish. Don't use fancy words like Leah said, because you might end up making them laugh. But just state them matter-of-factly. Like I didn't sound all crazy fluffy with my terminology. I said I was the point of call for a troublesome client.
Dozen.
Yeah. That was the way I worded it because that client was very difficult for my coworkers. So I put it very similar. Like I became the point of call for a problematic customer, making her no longer problematic.
So able to deal with difficult customers.
Yeah. Yeah, I didn't put it like that because I didn't want to call them problematic, but I just want to make sure it was clear that I was able to take a problematic customer and make them no longer problematic. I was able to resolve, the problematic issues. Like, it's been a couple of years, so I don't know the exact words I used, but yeah.
Sorry, Cliff. Nathan just put something in the chat about like a bar back as an example of a job. And I think what focus on is you probably have to make like decisions really quickly, and you probably have to manage like tons of different priorities.
Time management.
This or that.
Yeah, because that's what I was going to ask. Because it's like, I haven't really had a huge impact. I've been working at the same place for 5 years, but I mean, I haven't really had a massive
Here's something you may
impact.
not think about though. Have you ever done anything to reorganize the structure of like, let's say the liquor bottles to improve your performance, to be able to serve drinks faster?
It was pretty organized when they trained me, so I just kept it the way they wanted.
But at the end of the day, you're supporting a system. You're in a specific role in a system, and you're making tons of decisions and managing different priorities, and you're working as a team.
Yeah, there's a lot going on.
Oh yeah. And are you keeping customer satisfaction high? Could you maybe try to say that once you were made the bar back, could you say that maybe overall customer happiness went up at all? So I know bar back is like one of the top positions, isn't it? Or is that just the standard position?
It's kind of just doing everything bartenders do besides making drinks.
Besides, oh right, so I get it. Okay, you're still doing some important stuff. Yeah.
Yeah, it's a great supportive role.
Yeah. So teamwork, things like that. Keep those items in mind. That you're able to. So talk again. Because you're a supportive role. Talk about how you're able to make sure that the bartenders are able to do their job effectively and efficiently because of you. And talk about how you're able to improve their performance because of how well you do your job, for example.
Got it.
Attention to detail, looking for just standards that are required at any point.
Health standard, things like that, making sure you pass those things, all that kind of stuff. And like I said, we'll have more days to be able to review this stuff. I get another 30 minutes, damn it. When I get going, guys. I don't want to leave you guys hanging. I like helping you guys out. So I want to get you guys out of here. So I'm going to go ahead and get this link. I'm going to do the share link. It's going to be in the classroom, by the way. We're putting this in the classroom. What you want to do is go to it, go to file and do make a copy to make your own. And just put your name, resume. All right. Once you have it to a certain point, make sure to share and add my name to the share item. So you want to add me to it. So that way, if I need to, I can go in and also make some changes. Later on, we'll also be adding Arnell to it so that he can jump in. I always definitely rely on him to make certain changes because he's actually been in a hiring role before. So I'll make the initial changes and then Arnell will go in and make the final changes for you guys at some point. Because he has great knowledge on what companies are looking for, especially because he actually tends to talk a lot more to them, to the hiring managers at the companies we work with. Since I'm dealing with you guys, Arnell tends to go deal with the companies. So he definitely talks to them point on point what they're looking for. So he'll be able to make changes to your resume too. Sound good? So again, I'll give you guys a week on that. We'll probably do that again. We'll probably save this for Algorithm Monday again. So take your time on this, really think about it, but just get the basics down and start putting the basics on. I'll remind everyone tomorrow though, because I did do this late at night. So I'll remind everybody tomorrow. Right now. Any other questions?
On to
Right.
this time.
I'll see you tomorrow. I'm off.
All right, good night, everyone.
Bye, everybody.
Good night, all.
Good night.
Night, everybody.
Night.